Internet computer smart contracts have something that Ethereum and Solana smart contracts don't have that give internet computer smart contracts an edge, and that is stable memory. Today in this video, we're going to be talking about stable memory, why it matters, and how it actually applies to applications. So yeah, this is going to be more of a niche video, and people in the IC community haven't even really, talked about stable memory that much. And the way I kind of found out, about it and why it's so important. Of course, I look through everything I see, and I've heard of it before, but I've never heard of anyone actually using it until I started working for CongSwap. So CongSwap, we use stable memory, and I don't really know of any other projects in the IC that are using stable memory. There's probably some other ones that I just don't know of, but we use it at CongSwap, and you can go follow CongSwap at CongSwapX on X, the platform. And yeah, so let's get into it. So on the internet computer, we have these things called Canister smart contracts. It's essentially, a smart contract for the internet computer. If you're from Ethereum or Solana, you're probably familiar with smart contracts. All right. So as it says here, when developing projects on ICP, there are two primary forms of data storage that your canisters can utilize. The first type of storage is the canister's heap memory, sometimes referred to as the canister's main memory. Heap memory is temporary, and any data stored in a canister's heap memory is cleared whenever the canister is reinstalled or upgraded. The second type of storage available to a canister is stable memory. Stable memory is a unique feature of ICP that defines a separate data store aside from a canister's regular WASM heap memory data storage. Now, I'm not going to pretend that I'm not an expert on any of this right here. I'm just telling you guys what it is, and I'm going to give you guys kind of an example of why this matters in a little bit. But anyways, it is a secondary storage type that can be used to store data long term, since all data stored in stable memory will persist across all canister processes. And if we go down here, we'll see there's more on stable memory. Stable memory is a feature unique to the Internet Computer Protocol that provides a long-term persistent data storage option separate from a canister's heap memory. All right. Now we're going to go talk about why, and ChatGPT is going to be helping us here. I asked it a couple questions, and the first question I asked is, how is stable memory on the Internet Computer different than a smart contract on Solana? All right. So if we take a look at right here, it says the difference between stable memory on the internet computer and a smart contract on Solana primarily comes down to storage architecture, execution model, and use case focus. Here's a breakdown of the differences. So stable memory, persistent storage provided to canisters, can scale up to 100 gigabyte per canister, much larger than Ethereum-like contracts. Data remains even after canisters are upgraded. This is kind of the big, making it more like traditional file storage with smart contract capabilities. This is kind of the big thing that gives stable memory the edge, is the fact that the data remains even after the canisters are being upgraded. Now, an example of, where stable memory could have helped out a project, an example would be like Uniswap. So Uniswap, they have Uniswap v1, Uniswap v2, Uniswap v3, Uniswap v4. And the reason why is because their smart contracts are not upgradable, okay? And every time they want to redeploy a new smart, they got to make it a new version, etc. Which is honestly just more annoying and more difficult, rather than having your data in stable memory where you can continue to upgrade the canister and the data stays there, which is actually extremely helpful for developers. All right. Solana smart contracts. Solana contracts do not have persistent storage built in. Developers use accounts to store data, and storage is limited by account size constraint. To store more data, developers must use external solutions like IPFS, Arweave, or databases. Much lower on-chain storage capacity compared to IC. And this is kind of the big thing. Number two for execution model for the internet computer stable memory, upgradable smart contracts without losing data. That's kind of the big thing of this whole thing, is that you're able to upgrade the smart contracts without losing data. All right, so you don't have to redeploy new smart contracts every single time you want to fucking change things, which is very annoying and just makes things a little more difficult. Okay, so yeah, now we can go down, and I did Ethereum too. So I did how is stable memory on the internet computer different than an Ethereum smart contract. It just says here, Ethereum smart contract, storage is expensive. Canister upgrades do not erase. Canisters or contracts cannot be upgraded without deploying a new version. This is kind of the big thing with the Ethereum, as I mentioned, in this video, the Uniswap v1, v2, v3. And it's because contracts can't be upgraded without deploying a whole new one. And with stable memory on the IC, you're able to just continuously upgrade the smart contract. All right. Which is something that gives the IC an edge when it comes to development, which is very, very cool in my opinion. And I really don't have anything more to kind of talk about with this thing because I'm not an expert on the subject and I don't understand it extremely well, but I kind of wanted to make a video on it because it's something for CongSwap that we're constantly, talking about. Well, not constantly talking about it, but it's been brought up a couple times and I really hear nobody on the IC talk about it. So I think it's a pretty cool thing. And I think if you're a developer, it could be seen as something that could be, very, very attractive. I want to make one thing kind of known about the IC. A lot of people don't understand. You can build, because of the ICP's chain fusion, you can basically build a dApp for Solana or the Bitcoin market or the Solana market on the IC. An example of this would be like Odin.fund. It's built for the Bitcoin market, but it's built on the IC and leveraging ICP's tech. You don't have to build an ICP, dApp just for the ICP market, because the ICP market, if we're being honest, is very small and there's not too much liquidity. Compared to Solana, where you could build something for Solana and, have that bigger market, but you're building things on the IC, so you're able to leverage things like stable memory, etc., which are really, really cool. And if you enjoyed this video, make sure to go follow CongSwap at CongSwapX and follow me on Twitter at AaronBremser_. And yeah, thank you for watching.